Hey guys, how's it going? So yesterday I started working on the junction detection for the transport network. It's kind of rough at the moment, so if I quickly make this, if I make an overlapping spline, and we've got some rough detection going on. It's not perfect because of the method being used at the moment, so you sometimes get like double collisions. But it's mostly working okay, but I'm going to adjust the code for how it works. So at the moment, the way it works is we iterate over the control points of the spline, and then on the other spline, find the nearest point, and we check if it's within the threshold. What I want to modify is, instead of using the control points, we're going to define a resolution, and we're going to work our way along the actual spline itself, and then we'll check if the nearest point on the other spline is within the threshold. So this should give us a far more accurate result, and it will also allow us to have a bit more control over the accuracy, because we can adjust the threshold, also the resolution. So if we find we need it to be more accurate, we can make those smaller. If we want more performance, we can make them a little bit bigger, and that's fine. So it's this method here that I'm going to be adjusting, and I did move it into a utilities method. So it's now an external method. So in the transport network manager, when we run the method to detect junctions, we just call upon that static method. So it's completely isolated. To give you an idea of how this code's going to run, so similar stuff going on. We'll get the spline length. We'll then calculate the step size based on the resolution. So the length of the spline divided by resolution, that'll give us the step size. Less than resolution. Okay, yeah, distance along the spline, yeah. Then we'll get the location at that distance, okay. So as we iterate, that distance will get longer and longer as we make our way over the entire spline. Then this will be the same, so we're finding the closest point on the other spline, and then checking the distance is less than threshold. And because of that, we'll base the threshold off of the step size, so it's a little smaller. And if we need some more accuracy, we can make it smaller still. And it's given us some recommended units. Cool. So like always, I'm not going to copy and paste code. I'm going to write it out manually, because that will make it easier to just make sure we know what's going on. And it's generally better, helps you have a better understanding of how the code actually works. So we'll use it as a guide, but we won't necessarily copy it word for word. So I'll put that back over there for now. And then if I just make it easier, edit and canvas, so it makes it nice and big. Now it's nice and easy to see. And what I'll do, just so I'll keep this here for now, it's going to be a different declaration anyway, so we can just override this method and then delete this afterwards once we're happy. So if I go to game utilities, check spline overlap, so we're going to create another version of this instead of just straight up deleting it for now. Most of it's going to be the same. So that's the spline we're checking against. then this is the other spline. This is the actual overlap locations that we find. So now we want the resolution. And I want that to be float. Const float threshold. Okay. So because it has a different definition here, we can make this method first and then delete the old one afterwards, which is nice. Okey-dokey. So we'll pretty much do the same stuff as we've done here. So checking that we're not looking at the same spline and check that they are both valid, and then set up the variables we'll need. Okay. And then just to check to make sure they are valid. And this generally will be an issue, an error. Really shouldn't be passing a null pointer to it. Okey-dokey. And then, yeah, this next bit's going to be the same. Locations. Okay. Cool. Alright, so far that's the same. So now we're going to calculate the step size based on the resolution. Okay. Let's actually just skip that last, because then we can delete that first line. It's a bit unnecessary. Okay, so that would be the increments along the spline that we're doing. Okey-dokey. Okay, so now we're going to iterate over here. 4, 35. And that makes sense because we're dividing the spline length by resolution to give us the step size. So that should be the same number of steps we need to do. That does actually make sense, to be fair. And let's just do. Okay, cool. Okay, that's easy enough. Okay, so that should give us the location at the point at that step along the spline. Okay. Then the rest should be fairly similar. Okay, so what that does is, based on the outer point of the outer spline, find the closest point on the other spline to that point, and it gives us that. And then it should be the same check as what we had before. Then we need to add that to overlap locations. Overlaps.array. Cool. Okie dokie. So that should be working. So now let's call this method instead of the original one. And all we need to do here is add actually, one other thing we can do is get rid of or because we're going to calculate the threshold based on the step size, so we can pass in a threshold multiplier equals 0.5. Let's do that. Then if we do, after we calculate the step size, times threshold multiplier. Cool. Right on. Okay, so I'm going to do that. Do that. Let's build that. Cool. And then if I do something like that, okay. Interesting. In terms of performance, it's nice and fast. So it's maybe at least that's working, so we can delete this original one. Which is this here. And so let's firstly try making that smaller. Then if we need it to be more accurate, we can make the step size smaller. Okay, so now the threshold might be too small. Let's maybe go smaller step size. Okay. Let's maybe put that back to 0.5. visualize those points. Okay. So that's how we actually try increasing the step size. So I think it's just going to be a bit of trial and error, getting the right settings. This is probably skipping over that now. Let's make this 0.75. Okay, tell you what, let's world pointer. Okay. Just so then we can use the debug stuff. Call that here. Yes, we want this here. So this should show us all these steps where we're checking. And then what we can actually do is set the size of that debug. We'll make it a debug sphere and set it to the size of the threshold. Okay, cool. Okay, cool. So draw debug sphere. Game world. Outer point. So for the radius, threshold divided by 2. What am I missing here? So that will show us all the points that we're checking and then the actual threshold. Cool. That looks good. Okay, so still get multiple. Yeah, so that one in the middle gets a hit. Then potentially this one. Okay. So I think the resolution is fine. Actually, if I made the threshold smaller, we probably wouldn't detect this. So I think we make the step size bigger. Yeah, let's do that. Let's make this 100. Keep this at like high, it's like 0.8. So it will take up most of that. That should hopefully be a big enough step size where it will skip the next, won't have two hit in the same place. Yeah. So now we're only getting the one on the line. We're not getting multiples there, so let's just try to okay. Not quite what we want. But yeah, that's kind of an issue I thought we might run into, where they kind of run alongside each other. So for example, if I did something like this. Nope. Okay. Oh, never mind. Let's come over here. So it seems to be pretty good for like straight connections. Oh. But yeah, again, why are those different sizes? Actually, that does kind of make sense because the threshold is based off. Hold on. Yeah, that's about right. So we're calculating the step size based on the overall length divided by resolution. So the longer that spline is, it's going to adjust the step size. Really what we want is a consistent distance. And then the threshold based on step size versus threshold multiplier. Okay, let's use chat to help. So now, no matter how long the spline is, the actual spacing should be the same for the collision. Okay, that's fine. And then if we do a really long one, yeah, so now it's even spacing, no matter how long the spline is. So we now take a look at this. So really, we shouldn't be getting this second one. This one makes sense because it's falling into there. This one shouldn't do though. So I'm not sure why that is. That looks more like a miss to me. Okay, so now let's tweak some of these values now. So we go 10.5. So the first thing we need to check is, with the step size, do we reliably always overlap? And then we can adjust the threshold based on that. Okay. Okay. Yeah, that's given us multiples. So you probably want to make the threshold just a tiny little bit smaller. Seems good. Oh, good. Yeah, still doing multiples. So I think we actually want bigger step size, because if it's too small we'll get multiple points in the same place, but then keep the threshold quite high. So we go like 100, then keep this at like 0.95. So there should be more spacing in between. Not sure if that hot reload is actually taking into account those new sizes. It still doesn't really make sense because this is the last one we did. There's only that one that's actually intersecting. Yeah, something's not quite right there. Just check this code for a sec. Actually, that should be threshold, because we're checking the distance from that point. Let's actually see how that looks. Yeah, so they are overlapping, which is kind of interesting. Which, yeah, actually makes sense. Because the step size, yeah, so we're essentially doing a sphere collision. Each step is half of that distance. So we actually want to divide threshold by half. That should actually be correct. That's even worse. So we actually want to adjust this. This isn't quite correct. So step size divided by 2 to give us the half radius, not radius, and times by the multiplier. So for example, got a line we've got our step size. We then, so let's say that's 10. So we want our threshold to be that divided by 2. Or do we? Yeah, because otherwise the threshold is going to go all the way to the next step. We only want it to come halfway, and then the next one comes halfway. And then the threshold multiplier will just reduce that down a little bit. So that should be correct. Then, yeah, we can keep that kind of high. That should be fine. Let's see how that looks. Yeah, that'll be right. Oops. So we'll actually, because I was dividing by 0.5, it was actually making it bigger. There we go, okay. Cool. So now we need to make the step size bigger so we don't skip them. Alright, we're getting there. About 250. I'll probably keep this quite high, I think. Let's try that now. Now, make the first one. Okay, now we're getting there. Cool. So pretty good spacing. We could probably increase the threshold a little bit, keep it like 0.9. And let's see, when we do like something like this, yeah, we still have this slight issue here. It's a bit of a problem. So that'll be the next thing to tackle, but I think for standard ones, I'm quite happy with getting the accuracy there. So that's a little bit off, so we might want to change how we calculate the actual point in the middle. That made just one. Yeah, cool. Okay, sweet. So I think we're getting close. Yeah, it's just making one, so we're not getting duplicates on like normal crosses like this. This is something we'll have to address, because it will be the same issue when there's two splines running alongside each other. They'll keep on hitting each other along. So I'll have to go to the drawing board and have a little think about how that's going to work. But at least we're not getting those annoying duplicates anymore. They're not overlapping. Cool, if I do a bigger curve, like that. Yeah, that seems to be okay. Cool. And if we do text way through the whole lot, yeah, detecting junctions along there. Okay, cool. Alright, sweet. So yeah, it's getting pretty close. I'll leave it there for now. I'll have a little think about how to deal with the splines that are running alongside each other, or like a shallow curve. And that'll probably be the next thing to deal with. But it's getting there, getting close. Alright, cheers. I will.